Coming to the topic motion, we have different subtopics. Introduction to motion, which includes the definition and explanation, difference between distance and displacement, difference between speed and velocity, difference between average speed and average velocity, acceleration, retardation, and graphs which represents uniform motion, non-uniform motion, body at rest, uniform acceleration, non-uniform acceleration when acceleration is 0. And we have some kinematic equations for body moving in straight line with uniform motion. So which is equal to V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to 2AS. These are the three kinematic equations which will be solved graphically as well as in algebraic method. Then at the last we have circular motion. Coming to the introduction of motion, motion changes with change in time. That means as the position of the object changes with the change in time. So it requires a reference point for this. So motion is of different types. Few types of motion I have written here. One is motion in straight line in one direction, which is nothing but rectilinear or linear motion. Then circular motion as earth revolves around the sun. That we can take it as example of circular motion. Then vibrational motion, atoms have motion and they continuously vibrate. So this comes under vibrational motion. Then rotational motion, rotation of wheel, you can take as example for rotational motion. Coming to explanation of motion, what is actually motion described, how it is described. So motion is described respect to observer. For example, if a bus is going on the road and the observer is standing outside and looking at the passengers in the bus, he feels that the passengers are moving inside the bus. But the passengers sitting beside each other will feel that the person sitting beside him is not moving because he is not standing, walking or moving anywhere. So it depends on with respect to observer. So since we require a reference point. So motion is change in position of the object with change in time. So it can be described by taking following things such as distance, displacement, velocity, acceleration. These are describing factors for motion. So displacement is always in a straight line, whereas distance can take a curved paths. So whatever the total distance traveled will be nothing but the distance. But displacement is always shortest path from one point to another. We have 2 points here. So the arrow mark shows the displacement, which is the shortest path, and it's always in straight line. But in case of distance, it takes the curved paths. To understand the difference between distance and displacement is important because it follows with speed and velocity. Again, the same thing repeats. So, first we have to understand distance and displacement properly. Then coming to the differences. So, distance is the length, the total length of the path covered, whereas displacement is the shortest distance in straight line. It depends on the position also. Displacement depends on initial and final positions. For example, an object travels from A to B whose distance is 2 meters. Again, it came back from B to A whose distance is 2 meters. We take it positive, 2 plus 2, 4. But in case of displacement, the displacement will be 0 if the object travels from A to B and then B to A, because initial and final positions are A, the value will be 0. How? A to B it is plus 2 meters, B to A it is minus 2 meters. So it will be 0. It depends on the initial and final position, and point to be noted, it is the shortest distance in the straight line. And distance is a scalar quantity. What do you mean by scalar quantity? Scalar quantity means it depends only on the magnitude. What do you mean by magnitude? Magnitude means the value given to that particular distance is called as the magnitude. For example, 10 meters or 20 meters is magnitude or total path covered or distance covered. So distance depends only on magnitude, whereas displacement depends on both magnitude as well as direction. For example, if the body is traveling from A to B, it is plus 2 meters. If it is traveling from B to A, it is minus 2 meters. That means change in the direction is changing the value plus 2 minus 2. Hence direction is also important. So it is a vector quantity. Vector quantity means depends on both magnitude and direction. Scalar quantity means it depends only on magnitude. So distance can never be 0 and it can never be negative, but displacement can be positive, negative as well 0. So when it changes direction, it becomes negative, and when initial and final positions are same, it will be 0. Now coming to the difference between speed and velocity. As speed is equal to distance covered by time taken, or velocity is displacement by time taken. So units are meter per second and meter per second, both for speed and velocity meter units are same. It can be kilometers per hour also, SI and MKS units we can take. It is a scalar quantity. Speed is a scalar quantity. Why? Because distance is a scalar quantity and depends only on magnitude. Even speed also depends only on magnitude, and hence it is a scalar quantity. Whereas velocity is a vector quantity because it depends on both magnitude and direction, just like displacement. Then the rate at which an object covers a distance will never be negative or 0. But the rate at which an object covers direction with change in position or direction, velocity can be 0, negative or positive, just like displacement. Then average speed will continue to count the object's change in direction. For example, average speed, how do you count? It is total distance by total time taken. Whatever may be the path, it is total distance by total time taken. Whereas average velocity will be total velocities by number. For example, we have initial and final velocity. It will be v plus u by 2. That is average velocity. Then speed may or may not be equal to velocity, but object may have different velocities. Okay. Then coming to equation of motion, we have a graph over here which shows OA is u, which is initial velocity, and OE is v, which is final velocity. That means an object started at point A and with certain velocity traveled and it ended at point B with certain velocity at certain time. So we are not taking the velocity at 0 because initial velocity will become 0. We want some value for u, and this applies for straight line motion. Okay. Now coming to the things which are present in the graph, we have OA which is equal to u, OE which is equal to v, and coming to the parallel things such as OE will be equal to BC, which is parallel, and OA will also be equal to CD, which is parallel, and OC, which is time, will be equal to AD. This points to be considered because this we will use in deriving the equation. Now BC is equal to BD plus DC. That means this total BC is equal to BD plus DC. Just adding, in between D is there, so BD plus DC will be equal to total, that is nothing but BC. So we will get a form of equation that V is equal to BD plus U. Why? Because BC is equal to V and BD we don't know, and DC is equal to, this is nothing but this side, which is equal to U. So as we don't know BD, we will find out by taking acceleration is equal to change in velocity by time. So change in velocity is nothing but BD, which is V minus U, because this is total. If you minus this, we get BD. So BD by AD, which is equal to BD by OC. So acceleration is equal to BD by time, T, as AD or OC will be equal to time only. So this value, that is BD is equal to AT, we will substitute in this equation 1. So we will get V is equal to U plus AT. How? As BD is equal to V minus U, BD will be equal to AT, which is equal to V minus U. Simply we write V is equal to U plus AT, as minus U will become plus U when it comes to the other side. So this is the first equation of motion. We have to keep in mind that BD is equal to AT. Why? Because same thing we use in the second equation of motion also. So here if you take a part of the graph which contains a rectangle as well as a triangle. So rectangle OADC area, if you want to take, it will be OA into OC, length into breadth, plus half base into height. What is base? AD. Height is BD for the triangle. So this we are taking it as distance. So because distance is equal to velocity is equal to displacement or distance by time. So if you want to find out the distance, it will be velocity into time. So which is nothing but the area inside. So S is nothing but distance. S is equal to UT plus half AT square. We got from OA is equal to U, OC is equal to T, then half is same, AD is T, BD is nothing but AT from the previous equation. So this shows the relation S is equal to UT plus half AT square, shows the relation between position and time. Then we have the relation between position and velocity. So we will take total this as a trapezium and we will take the area of trapezium, which is nothing but sum of parallel sides OA plus BC into OC, which is nothing but height divided by 2. So OA is nothing but U, BC is nothing but V, OC is nothing but T divided by 2. So as we know, VA is equal to V minus U by T. So T will be equal to V minus U by A, just interchanged. Then by using this V minus U by A is equal to T, we just substitute and we get S is equal to U plus V into U minus V plus U into V minus U by 2A, which is nothing but in the form A plus B into A minus B is equal to A square minus B square, which is nothing but V square minus U square. So S is equal to V square minus U square by 2A. So 2A will go the other side. So V square minus U square is equal to 2AS. So with this we have solved all three equations with a graphical method. Suppose if you want to solve it in the algebraic method, we have to use for the first equation, that is V is equal to U plus AT. We take acceleration is equal to V minus U by T. So V minus U is equal to AT. V is equal to U plus AT. This becomes the first equation of motion. Then coming to the second one, we have to take distance is equal to average velocity or V, average velocity into time. So the average velocity is nothing but V plus U by 2 into T. So as we know from the equation, A is equal to V minus U by T. T if exchanged, we get V plus U by 2 into T is nothing but V minus U by A. So V square minus U square again. So V square minus U square by 2A. Okay, this becomes the third one. We will solve the second one. V square minus U square is equal to 2AS. Now second equation, as I have solved third first. So same thing you take, s is equal to velocity into time and v plus u by 2 into t. Now instead of t, we will substitute the value of v here. From the first equation we know v is equal to u plus at. So just substitute u plus at plus u into time by 2. U plus u will be 2u plus at into t by 2. Now we will just open the brackets. We get 2ut by 2 plus half at square. So u2 and 2 will get cancelled. We will get ut plus half at square. So s is equal to ut plus half at square. So simply we can solve the 3 equations of motion using algebraic method.